Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 3.2.1. We've got some M&Ms here for evaluating algebraic expressions. So in our last M&Ms, we were talking about numerical expressions and the order of operations. In this case, with algebraic expressions, you simplify it by combining like terms, but the term evaluate means once we know what x and y are equal to, let's plug those numbers in and simplify it as if it were a numerical expression. So basically, evaluate means find the value of this expression for these given values of x and y. So the only way you can do it is if they do give you values for x and y. So in this case, we're going to take 4x minus 3y plus 7, and we're going to say x is equal to 2. So let's go ahead and find out what that is equal to. 4 2's would be equal to 8, correct? And then we're going to say that y is equal to 1. So 3 1's would be equal to 3. So we're going to take 8 minus 3 plus 7. And because this expression is only addition subtraction, you just go from left to right. 8 minus 3 is 5, and 5 plus 7 is just 12. So this expression, after being evaluated for x equals 2 and y equals 1, has a value of 12. All right, so let's take a look and see what we've got here. It says the number 6 is represented with positive and negative tiles at the right. I don't like this mess. Get out of there. Let's not have you there right now. Okay. So can we all agree on that? This is 1, 2, 3, 4, 5, 6, 7, 8, 9 positives plus 3 negatives results in 1, 2, 3, 0 pairs. So yeah, you get 6 for an answer. So yes, I agree with that. It says for each problem below, start with this diagram and then show how you would remove the appropriate number of tiles to represent the problem. Okay, so if we start with 6, and I know this kind of looks like a mess, but I think you can see it okay. If we start with 6 and we try and take away 7, you've been lied to for a long, long time, where your first and second and third grade teacher says, no, you can't take 7 away from 6. That's illegal. You don't have enough to begin with. And then you learned about the positive and negative numbers. It's like, oh, well, if we're willing to write our answer as a negative, then yes, we can do that. So 6 minus 7, if you see it on a number line, is pretty straightforward. You start at 6 and you go back 6 units to 0. Then another unit takes you to negative 1. Or here with the algebra tiles, we agree this has a value of 6. So when you take away 7, 1, 2, 3, 4, 5, 6, 7, all of those are gone now, leaving you with 2 positives and 3 negatives. And then you take these 2 0 pairs, they go away, leaving you with just the 1 negative. So this is a model for 6 minus 7 gives you an answer of negative 1. Now, if I were to use KFC here, and say instead of 6 minus 7, 6 plus a negative 7, now I can model this with 1, 2, 3, 4, 5, 6, and 7 negatives. And here's a 0, 0, 0, 0, 0, 0. We get the same answer, negative 1. I think it's easier to add a positive to a negative than it is to try and take away numbers when we're dealing with positives and negatives. So I would prefer that you did KFC here, but you don't have to. There's a way to model this without doing KFC. Here, same idea. You start with 6. This has a value of 6. And then you're going to take away 2 negatives. So these guys go away. And then you've only got 1 0 pair there instead of the 3 0 pairs that we had up here. So now what do we have left over? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 positives left over. So let's show this again using KFC. If I instead say 6 plus the opposite of negative 2, you can clearly see that our answer is going to be 8. And this is much, much easier to solve than that guy is. And then here, 6 minus 3. Start with the 6 configuration, take away 3 positives. Look at your 0 pairs. What's left over? Positive 3. Well, we know that 6 minus 3 is equal to 3. We've been doing that since first grade. But let's see what it would look like if we did KFC. If we did KFC, we would start off with 6, right? And then instead of subtracting 3, we would add a -3. And we learned a few weeks ago that when you add positives and negatives together, 1, 2, 3, 4, 5, 6, and then 3 negatives, that you form 0 pairs. So it actually is a subtraction problem. And you keep the sign of the bigger number. 6 is bigger than 3. 6 minus 3 is 3. Yes, we see the 3 there. So we've got multiple ways that we can model these types of problems to prove that these answers are the correct answers. All right, now let's take a look at some absolute value types of concepts. Use a number line to show the distance between the two given integers. Plot each point as a point on the number line and then find the distance between them. Now remember, distance is never expressed as a negative. It's just as a number of positive units. So this is the idea of absolute value. How far are 7 and 4 away from each other on the number line? They are 3 units away from each other. It doesn't matter if you go 4 minus 7 or 7 minus 4. If you always take the absolute value, you're going to get positive 3 for your answer. How far are 5 and -2 away from each other on the number line? Well, 1, 2, 3, 4, 5 units just to get to 0, and another 2 units to get to -2 gives you a total of 7 units. Now, if you had taken 5 minus a -2, that would be the same as 5 plus 2, and you'd get 7 for an answer. But if you went in the other direction, -2 minus 5, you get -7. But once again, we're talking about distance between the 2 points. We never express distance as a negative, so we will take the absolute value of that and say the answer is 7. Now, a little bit of a trick here. If you always put the greater number first in the subtraction process, you'll always get a positive answer. -1 minus a -3 is going to be -1 plus 3. And -1 plus 3 is equal to 2, correct? So that means that these 2 points on the number line must be 2 units away from each other. Okay, so this is part of the reason why we learn about absolute value. It's not just some neat trick for us to talk about and learn about. There actually are some practical applications of using absolute value expressions. And this is one of them, finding the distance between 2 points, especially if one of them is in the positive and the other one is in the negative. All right, consider the expression 5. Why do I have this crossed out? Consider this expression. 5 plus 4 plus 2 times -3 plus 7 plus -5. Draw this using algebra tiles. All right, so here's the 5 right there. There's the 4. Here are 2 groups of -3, so you get -6 there, right? And then here are 7, and then you've got the -5, which I don't know why I crossed those out. Why are you crossed out there? Let's not do that yet. In fact, let's go ahead and get rid of all those. So that would be the expression. Simplify to find the number that this represents. And so, all right, let's take, I guess, what do we have here? We've got 0 pairs here. So we took away 6 positives and 6 negatives. And I think if I crossed all those guys out, didn't that mean I was also supposed to cancel out all of these guys? I think so. So let me go ahead and do that. So those guys form 0 pairs, leaving you with 1, 2, 3, 4, 5. So this must have an overall value of positive 5. It says remove, oh, that's why that's there. Okay, so remove the last number from the expression. So you're essentially taking away -5. So this becomes 5, a model for 5 minus a -5. Because the original expression had a total value of 5, and then you take away the -5, what does that leave you with? Well, that means that we're no longer going to cancel out those 5 positives with these negatives because we've taken those away. They're not there to cancel out anymore. So now you've got these 0 pairs, and you're left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's look at this again. We take the original expression, but without the -5 at the end. Now we've got a 0 pair here to go with this guy, a 0 pair here to go with that guy, and you're left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 minus a -5 is the same as 5 plus a positive 5, which gives you 10 for an answer. All right. Oh, I love these models for showing us how algebra works. Jorge was thinking about using variables to represent lengths on the tightrope. So he wrote this, x plus x plus x plus x plus 3. So that's the same as saying 4x plus 3, correct? So that means 4 steps that we don't know how long those steps are, right? They're unknown. If we knew how long they were, we wouldn't call them x's, we would just write in the number. That's what these unknowns are representing. 4 equal steps of unknown length plus 1 step of 3 feet. Now it says write an expression to represent this. And so you've got 2 unknowns here plus another 3 unknowns there. And we can't call them 5 unknowns. I mean, they are 5 unknowns, but the j's are a different length of step than the k's. So we want to separate those into 2 j's plus 3 k's. And says now, if part A, if x were equal to 5, this would become 5 plus 5 plus 5 plus 5, which is 4 times 5, which is 20, plus 3 is going to be equal to 23. And if j is equal to 3, 1, 2 3's, and 3 2's, then you end up with 2 times 3 plus 3 times 2 ends up being 6 plus 6, gives you a final distance of 12 feet on that tightrope. And now for the last problems of our homework. Being able to add, subtract, multiply, and divide fractions is very important for middle school students. You want to master these before you head off to high school. So when you're adding fractions or subtracting fractions, you need a common denominator. And if you recall, we talked about using the coat of arms. Sometimes that's the easiest thing to do. If you can't determine what the greatest common factor is of these 2 numbers in 3 seconds, just multiply. 3 times 3 is 9, 4 times 2 is 8, and 3 times 4 gives you 12 for each of your denominators. You now have equivalent fractions to the original 2 that have the same denominator. And now you can add straight across to get 17 over 12, which is the same as 1 and 5 twelfths. Here, you could do the coat of arms, but since it looks pretty obvious that 4 goes into 8 twice, we could change this to an equivalent fraction of 2 over 8. And then subtract, you get 5/8. Now, let's say you didn't notice that. What would we get instead? We would get 28 over 32 minus 8 over 32, which gives us an answer of 20 over 32. And you just need to simplify this fraction by dividing the top and the bottom by 4, and you will get the correct answer. So sometimes doing the coat of arms forces you to simplify fractions, not always. And even when you do find least common denominator, you sometimes still have to simplify. So, you know, if you don't know what the least common denominator is or the common denominator, just do coat of arms. It works just fine. When you're multiplying, you don't need common denominators. You just multiply straight across. So 3 times 1 is 3, 5 times 3 is 15. And if you saw this and you recognized, hey, wait a minute, I see a giant 1 lurking in there. 3 divided by 3 is 1. So I can cross cancel those and just get an answer of 1 over 5. In this situation, there are no common factors to form any giant 1, so you're just going to have to multiply straight across, and that ends up being your answer in simplest form, because 8 and 21 have nothing in common other than the number of 1s that cannot be simplified. All right, another relatively long homework, but lots of good information in there. So let's move on to our next phase, which I believe is probably your next lesson. Take care. Bye.
Hey, feeling good, like I should.